Here's 2015 question 6. Based on this, it's looking like a slope field separable differential equation problem. But if you look at the actual questions, it's probably just a generic one. It doesn't really fit into anything. But here we go. Write an equation of a tangent line. Okay, so remember, this should be your buzz phrase, okay? You see it so often in every FRQ. To make an equation of a tangent line, you need two things. You need a point, which they already give. All you're missing is a slope. Slope is pretty much your derivative right there. So if you plug in -1 and 1 for x and y, respectively, you should get 1/4. So that'll be y minus the y coordinate equals 1/4 times x minus the x coordinate. And there you go. Or you could change that to a plus if you wanted to. It's up to you. Equals equal. They got y by itself. It really doesn't matter. Okay? Here's part B. Find the x-coordinates of all points on the curve, which the tangent line is vertical. So the buzzword right here, you guys, is vertical. What does it mean to have a vertical slope? What do you guys know about that slope? Okay? So you should know that this slope is undefined. Well, think about it. What does undefined mean? So that's pretty much when you're dividing by 0 or when 0 is under. Okay? So if we could make this equation undefined, we can find out where the x and y coordinates are. So we pretty much have to make the bottom equal to 0. Okay? So this is pretty much what they have in the scoring guidelines right here. So if you solve for x, or just add x to both sides, you should get x is equal to 3y squared. Okay? So this is pretty much the equation where all slopes are undefined. So what you do is you plug it into the curve. So here what we did was x is going to be replaced by a 3y squared, because that's what it's equal to. We do that because you can't solve for two variables at once. Okay? So we're limiting it so that all of it looks like y's. Okay? So here, let's see. We have y cubed minus 3y squared cubed. If you multiply that out, we know it has to equal 2 based on the equation. That comes out to negative 2y cubed if you combine like terms. And if you go far enough solving for y, you should get y equals -1. Okay? So now that we know that y is -1, we plug it back in. Okay? And then now our only missing variable here is x. If you solve for x, you should get 3. So you found out the point where the tangent line would be vertical. Okay? Not too common, but this does pop up a lot in BC should you ever take BC or anything past your first round of calculus. Okay? Here's part C. Evaluate the second derivative at this point. Okay? So here we go. We know that dy dx is equal to y over 3y squared minus x. So we have to take the derivative again. So it's pretty much like solving or finding differentials, okay? Here I notice that there's a giant quotient. So I have to apply the quotient rule. So here we go. Quotient rule, we start with the bottom. So bottom times differential of the top minus the top times differential of the bottom all over bottom squared. Okay? So here we go. derivative or differential of the top, the derivative of y is just 1. So the differential is just dy. Okay? The bottom here, the differential of the bottom is going to be 6y dy minus 1 dx. Okay? I put a 1 there for a reason you'll see in a second. Now we got to divide every differential by dx. Okay? Notice how these dx's go away. Okay? So the only thing you have to do now is replace your dy dx's with what it is equal to initially. Okay? So I'll write it here. It's going to be 3. I'll color code this. It'll be 3y squared minus x times something minus y times 6y times something minus the 1 all over 3y squared minus x quantity squared. So it does get a little bit messy, but here we go. I know that dy dx is equal to y over 3y squared minus x. So plug that in here. And although it's super messy, equal is equal. Okay? They do ask you to do one more thing. They want you to evaluate it specifically at -1 and 1. So I won't do this last part, but basically you got to plug in your x and y values. It is a lot to write out, but the good news is you don't have to evaluate it. Okay? And that's it.